So guys, this will be the last video in figuring out how to make the equation of an exponential function from a table by hand. I will do a video later on about how you can do what's called an exponential regression. And I'll write it down here just so you can see what it's called, exponential regression. That is a way, it's where you take a calculator and you actually just type in the values from the table and the calculator comes up with the equation for you. It's pretty cool, but we'll get to that later on. So for these tables, the two tables we're going to look at in this video, what makes them different is that the x values are not changing by 1, okay? In this table specifically, the x values are changing by 3. It's important to recognize that because when the x values do not change by 1, then you have to do something else to get your factor. On the other examples that we did in the other two videos, all of the x values were changing by increasing by 1. And then we got our factor just by looking at the y values, looking at what were they being multiplied by to change each time. So you're still going to do that in these tables, but because the x's are changing by something other than 1, that means that you've got another step that you'll have to do to figure out the factor, okay? So let's actually do that part now. So when we're looking at our y values, we see that they are increasing, all right? So this table does show exponential growth. So then you've got to find two numbers next to one another where you can tell pretty easily what they're doing. How is one number being multiplied to go to the next? So the easiest two numbers here to use are 2 and 16. 2 times 8 gives us 16, okay? 2 times 8 gives us 16. If you plug it into the calculator, 16 times 8 would give us 128. 128 times 8 gives us 1,000 and 1,024, so on and so forth. Same thing with that 0.25. If we multiply it by 8, we get 2. So instead of using that 8, though, as your factor, what you've got to do is you're going to take a root of that 8, okay? But how do you know if it's going to be a square root, a cube root, fourth root, whatever it might be? That's where this plus 3 comes into play, okay? If the x's had been changing by 2, that means you would be taking a square root, okay? And normally with a square root, we don't write anything outside of that radical symbol. And that would mean that you would figure out what number times itself twice gives you 8. Here, though, because the x's are changing by 3, you're actually going to take a cube root, which means you've got to figure out what number times itself 3 times gives you 8. So this one is a fairly basic one, guys, okay? But if you're ever not sure, just start trying numbers, okay? So think 3 times 3 is 9, so that's already greater than 8. That's not going to work, okay? Well, 2 times 2, that gives us 4, and then 4 times another 2 gives us 8. So if you have 3 2's being multiplied together, that equals 8, okay? Because of that, then, the cube root of 8 is 2. So what we're actually multiplying by in this table, what our factor actually is 2. And it'll make a little bit more sense, guys, when we start putting in some of the x and y values that are missing. So what we're going to do here is we're going to make the table again, but we're going to include the values that are left out. So the table starts with -1 and 0.25, okay? So then to go to 0, to go up by 1, we're going to try multiplying by 2. So 0.25 times 2, all right, that gives us 0.5. Okay, so let's do another one. If we go up to 1, 0.5 times 2, that gives us 1. Okay, what about when x is 2? 1 times 2 gives us 2. When x is 3, 2 times 2 is 4. When x is 5, 4 times 2, or sorry, I skipped 4 there. When x is 4, 4 times 2 is 8. And then when x is 5, 8 times 2 is 16. So the table that the problem gave you left out a bunch of values. But once you figure out what that factor actually is, you can then go back through and figure out all of those missing values. And what you need to notice is this. The values in the table that the problem gave you, these first 3 values, we got those exact same values in the table that we just made. But we also included those values that had been left out as well. Now, do you need all of those values? No. All you really need at this point is you've got your factor, it's 2, and you need your y-intercept, which is 0.5. So the equation that goes with our table, really both tables, is y equals 0.5 times 2 to the x power. Okay? But this is how, this is the actual table with all of the values filled in. Okay? And if you're ever not sure if your equation is right, plug it into your calculator, go to the table that the calculator generates, and see if the values in that table match the values in the table given to you by the problem and the values in the table that you created, okay? So let's do one more of those. So on this one, the x's are changing by 2's, okay? And we already have our y-intercept. It's 512. So that's one less thing for us to find in this problem. But what we've got to notice here is that as the y value, or as the x values are increasing in this table, the y values are decreasing. So this table is showing exponential decay. So exponential decay, let's think about it for a moment with division. Let's take the 2 numbers here that are probably going to be easiest to use. 32 divided by what gives us 2? Well, that's 16. And if you weren't sure, just say 32 divided by 2, that gives you 16. That tells you what to divide the 32 by. So that means, guys, that to go from one term to the next throughout this table, we are dividing by 16, okay? Now, we mentioned in the earlier videos how when you make your equation, you don't write it using a division. You have to write it through using multiplication. Well, here, though, because the x's are changing by something other than 1, you've got an extra step there to figure out what the factor actually should be, okay? So what you're going to do here is you're going to take a root of that 16. But because you were adding by 2 each time, you're going to take a square root, all right? On the example that we just did, we took a cube root, all right, because the x's were changing by 3. Here we take a square root because they're changing by 2. If they had been changing by 4, you would take a fourth root. So by square root, what that means is you've got to figure out what number times itself, so what number multiplied twice, gives you 16. Well, that's 4, okay? So if we were to fill out some of the missing values in that table, so negative 2 is at 8,192. If we wanted to figure out what the y value was when x was negative 1, we would just say 8,192 divided by 4, which is 2,048. Then if we divide by 4 again, we get 512, which matches that y-intercept that we had in our original table. Now, I'm not going to finish the rest of the table, guys, but the pattern would be the same. You would continue to divide by 4, all the way through. But so to make the actual equation that we need, the a value, our y-intercept is 512. But instead of saying 4 dividing by 4, we've got to think dividing by 4 is the same thing as multiplying by 1/4. Okay? So our b value is 1/4. So our equation will be y equals 512 times 1/4 raised to the x power. All right, and that's it.